particles of matter are very small. Yes. How small are these particles are made up of? So here, this is one more activity or the evidence. We can say that the particles are very, very small. Okay, they are very, very small. When we consider any matter, we can say that the matter consists of particles. With one evidence I have already shown. One more evidence is that the particles are very small. Okay, so what is that evidence? What is that evidence? Evidence is nothing but an activity. Prove statements or prove experiments. All this considered as evidence. Alright, children? Okay, so here to prove that how small are these particles of matter, so again take a beaker. We are convenient to take 100 ml of beaker in the laboratory. Yes, children? Or take 200 ml of beaker, any volume, okay? But add 100 ml of water in it. How much ml? 100 ml of water in the beaker, and add, here I have given in the activity 2 to 3 crystals. 2 to 3 crystals, but take one spatula full of KMnO4. What is KMnO4? Potassium permanganate. Okay, here we have taken the reagent called potassium permanganate. The formula of potassium permanganate is KMnO4. K stands for potassium, and Mn stands for manganese, O stands for oxygen. Understood, children? K is the symbol for potassium, Mn is the symbol for manganese, and O is the symbol for oxygen. Okay, this is the compound we have taken here. The compound is nothing but potassium permanganate. The potassium permanganate is taken in the beaker containing 100 ml of water. And what we are using here for stirring? We are using a glass rod. A glass rod is used to stir continuously. Understood, children? Here we have taken the glass rod. Glass rod is used for stir. So when we stir completely, what happens? The solution turns to pink. So take one more beaker. Add 100 ml of water. What is the water? Take 100 ml of beaker and add or transfer 10 ml or 40 ml from it. So simply we will transfer 10 ml from this and add in 100 ml of plain water. Okay, and dissolve it with the glass rod. And take one more beaker. Take 100 ml of water and add again 10 ml of solution from
Ma'am, your voice is not clear.
It's not clear, dear? Yes, it's okay? Now it's audible? Yes, ma'am. Yes? Okay. So here 10 ml of solution from first beaker to the second beaker. Again we'll dilute it with the glass rod, mix it with the glass rod, and again dilution from second beaker to the third beaker. Again 10 ml we'll take and we'll dilute it. What will you observe? And repeat the experiment up to 5 to 8 times. How many times, children? 5 to 8 times or 5 to 6 times. Repeat the experiment. So what did you observe? By doing this activity, what did you observe? We can see that here, the first beaker, the concentration of color is also a physical property. The concentration of color is very high. The concentration of color is very high. We can see the dark color. When we see the second test tube, the color compared to first one, it is lighter. And the third one, slightly faded. Like that, the color gradually fading off or diluted from first concentrated beaker to the last concentrated beaker. But is that the last concentrated beaker is plain or normal water? No. Though it is keep on taking many times of dilutions also, the last beaker also consists of very minute particles of potassium. The color we can see. Understood? This means that the particles of matter are very, very small. That means beyond our imagination, they just break themselves. And the splits themselves and they transfer from one beaker to the other beaker. Understood, children? Understood?
Yes, ma'am.
Okay, by this evidence, we can simply say that how small are these particles of matter. Children, see here first 100 ml of water. There we have taken few ml or a few crystals of potassium permanganate. What is the formula of potassium permanganate? I have showed you. KMnO4. Very good, Harishri. KMnO4. Okay. This potassium permanganate, when we have added in the first beaker with constant stirring, so that it completely dissolves in the first beaker, so that we have a...
Now, what is the formula of potassium permanganate?
KMnO4. Capital K stands for potassium, Mn stands for manganese, capital M is for N, and capital O.
Now, can you light? Now, your voice is not clear.
Oh, it's clear. It's clear, Abhishek?
Yes, it's clear.
Yes, yes. The rest of these, mute your microphones, children. Please. There's a very big disturbance here. Please mute your microphones and listen. Just listen. Okay. In the first beaker, we can see that concentration, higher concentration, and dark color. And from there, from the first beaker to the second beaker, we can see that slight difference in color, but it's not that much. It's quite negligible. And we can see the third beaker, it's completely or almost diluted, like that the concentration of the particles have slightly dropped out from the first beaker to the last beaker. But here we can see that the last beaker also, though it is dilutions are too strong, but even though we can see that the slight change in the last beaker also. This evidence mainly shows that the particles of matter are very small. Understood? They are very small. They break themselves into smaller particles and they divide by themselves and they mix up with the concentrations. Understood? Understood, children? Here we have taken potassium permanganate. What is the formula of potassium permanganate? KMnO4. Understood? What is the color of potassium permanganate? Pink or magenta in color. You can see the observations. Color change. Yes? It's a pink or magenta color, and after dilutions, we'll feel that it's a purple in color. Okay? Potassium permanganate breaks down to individual particles when they dissolve in water. This is what happens with salt and sugar also. But we can't see the color change over there. This is also a complete dilution or completely dissolved. The potassium permanganate completely dissolves in water. They occupy the spaces between the water molecules. But there is no rise in the water level. Same. But here we can see the color change, how dilutions takes place. Okay. So here we have transferred the samples like 10 ml only. Okay, 10 ml from 10 ml is how much small are the particles. But these small particles also divide into huge number of particles and they transfer from first beaker to the last beaker. Simply we can see in our dilutions. Now we understood now how small are these particles of matter by doing the evidence like activity like beaker. We have taken different kinds of beaker, like different number of beakers, and we have diluted the beakers with potassium permanganate. We dissolved it and we have transferred 10 ml from each of the beaker. Understood here? Children? So we can see the dilutions from the first beaker to the last beaker and we can observe the color change. How the color change diluted and faded from first beaker to the last beaker, so that we can say that the particles are very small. So they break by themselves, or they split by themselves beyond our imaginations and they transfer from first beaker to the last beaker. What is the final conclusion for this evidence, children? We conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keeps on dividing themselves into smaller and smaller particles. Understood? Okay, note. The particles of matter are very small. They are small beyond our imagination. We can't imagine it how much they are small enough. Okay, we can't imagine it that much small. They split by themselves and they dissolve it in the water. So that these particles, if you have taken one drop also consists of these particles, solute particles like potassium permanganate particles.